I want to revisit section 12.8, estimation of mean value and prediction for individual value of y. In sheet 1, I have worked this out, and some of the information comes from the top table where we did these computations. And the question is, do we need to do all of this to be able to work the problems out that involve in the test for confidence interval and prediction interval, something similar to section 12.8? Well, the answer is no, you don't have to do all of that, but still it's not like there is just one simple formula. But let me show you a way of getting the information that you need in a relatively quick way. So I have copy pasted the data from section 12.2, and here we have annual sales as the dependent variable, and profile number of customers in millions is the independent variable. Now I have already run the regression, and the regression results are shown here, and now we'll jump into section 12.8 where we want to compute a 95% confidence interval, and the formula for that is this. So here is the point estimate, this is the t table value, and this part is the standard error of y hat, which is right there. Now for this formula we need all of these little pieces of information. So we can get n from the summary output, number of observations right there. Now x bar, this is you have to compute this using the Excel function average. So that's your x bar right there. Now SSX is sum of squared deviations of x from x bar. That is, we have to subtract x bar from each x, square that, and add them up. And that's the time consuming part. Unfortunately, there is a function in Excel that is DEVSQ, deviation square. That function does the computation for us. If you give a range of values, then it will subtract x bar from each value, or the average from each value, square them and add them up. So this gives you the sum of squared deviation, that's the denominator. Now that part, S sub yx, is from the regression printout, okay, results, which is here, standard error. Now we want for 4 million customers a prediction for y, so x is 4, confidence interval is 95%. So now we can now compute y hat. Y hat is intercept plus slope times x. Now we want the numerator, which is for this particular x, we want x minus x bar squared. So that will be x minus x bar, and you square that. Okay. Now we will take this part alone inside the square root and we'll call that h sub I. Let's go ahead and compute that. So that will be 1 over n plus this value divided by SSX, which is that. So that gives you the h sub I value. Now we are ready to compute this whole thing, which is that times square root of h sub I. So S sub yx times square root of that. Okay, now degrees of freedom is always SSE degrees of freedom, residual degrees of freedom, which is that. So T is T dot INV dot to T. Okay. probability is 1 minus the confidence level, comma the degrees of freedom. Will give you the t value, and then you multiply t with the standard error of y hat, so that will give you the margin of error, and then you can take y hat minus margin of error will give you the lower limit, and y hat plus margin of error will give you the upper limit. So this is your confidence interval. And for prediction interval, then you would work this out exactly like what I've demonstrated in section 12.8. So that will be S sub yx, that's your standard error of the regression, times square root of 1 plus h sub I. We've already computed h sub I here, so 1 plus h sub I. Then t is the same t, so we can simply say equal to that. And then the margin of error is t times that, and the limits are y hat minus margin of error and y hat plus margin of error with the upper limit. So that's our prediction interval. So you still have to do some computation, but you don't have to set up all the different columns like x minus x bar, y minus y bar, and so on. You can set up this template and then keep it ready, and when you do the test, you convert the data into Excel and then copy paste it here and do the rest of the computations here.